equilibrium problem that has a block sliding on an incline at an angle of 20 degrees with a mass of 1.5 kilograms and a hanging block over a pulley, which is frictionless, and a massless, stretchless string. The mass is 0.2 kilograms, hanging straight down, not rubbing against the side, so there is no friction. The coefficient of friction in the situation is 0.2 between the sliding block and the board, and I would like to solve for acceleration and tension. The first thing I'm going to do is draw my free body diagram. So I'm going to have two free body diagrams because there are two objects, and they will be treated separately in the force equations. For the sliding block, I have force of gravity straight down, the normal force perpendicular to the incline. My hypothesis is that the system is going to move to the right, so resisting the motion will be the force of friction, and then the force of tension in the direction of the rope. That's one free body diagram. For the second block, there will be force of gravity, because it's on Earth, and force of tension, and no other forces. Now, in order to analyze this problem, I'm going to have an X and a Y triangle for this, and or an X and a Y force equation for this block, the sliding block, and only a Y for this one. So let me do sliding block in the X direction first, because I will end up needing all three force equations. So in the X direction, the sum of the forces in the X direction will equal mass times acceleration in the X direction. And let me think about the direction it's traveling. It's going to be speeding up to the right, because my coordinate system, this is my Y and this is my X. It will be moving in the positive X direction, so this acceleration is positive. Equals force to the right is Ft, force to the left is Ff, and the third force acting in the horizontal direction will be, use a different color so you can sort of see where I'm going here. I will have Fgy as this component, and Fgx as this bottom component. Here's my right angle. And to get an angle inside the triangle, well, I can see right now that my component is going to the left, so it's going to be minus Fgx. Then, sliding block in the Y, also this block over here, I will have MAY equals, up is Fn, minus down is Fgy, this component of gravity. Right? And for the third equation, may as well get all my equations done before I do any algebra here. Get the physics out of the way first. Is, whoops, hanging block. My eraser there. Yep. Hanging block. This one I only have to worry about the Y direction because there's no horizontal component. So this is my Y right here. MAY equals, let me think about the direction. I'm hypothesizing it's going this way, which means speeding up in the negative direction. So we'll have a negative. equals up minus down, so Ft minus Fg. All right, so let's take a look at our gravity triangle first, because I need components for here and for here. So if I scroll down and give myself some more space, I'm just going to reproduce my gravity triangle right here, so you can see clearly what the three sides are. Okay. Now, this right triangle right here that I'm outlining here, there's my right angle. This is my 20 degrees that was given in the problem. This right here will be the complement of 20, which is 70. Now, there is also, with the board here, this is my 70 degrees. This right here is a right angle. So if this is 70 right here, this has to be 20 right here. So that locates the angle inside my gravity triangle of 20. Now, I already know the force of gravity in this situation, because we know in any circumstance that force of gravity equals mass times the acceleration of gravity, and the mass of our block is 1.5 kilograms, because that was given, times our acceleration of gravity is negative 9.8, and that is equal to negative 14.7 newtons. So this is my hypotenuse. So to find my two sides, I will use sine for this one because it's opposite, and cosine for this one because it's adjacent. I'll just give myself some more space. So sine 20 equals FGX over 14.7. Now remember, the magnitude is what we use on the sides of our triangle to find the sides, not the direction, which we used to show that the arrow is pointing downward. And then cosine of 20 is equal to FGY over 14.7. So let me go back to my equations here, and I can substitute in a little bit of information. I know my mass is 1.5. I don't know what A is. I'm just going to leave that as variable. Equals Ft, don't know what that is, minus, we know this is true from when we studied the force of friction, so I'm going to substitute in mu Fn for my Ff right here, minus Fgx. We go down here, and I solve for Fgx. This gets multiplied by both sides, so I get 14.7 sine of 20 like that. Now I'm going to do the same thing for each of my other two, just to put in as much information as I know so I can solve. Let's think about this acceleration right here. This block is accelerating in this direction according to my hypothesis. Even if I'm incorrect and it's sliding this way, it is still not going to be accelerating perpendicular to the board. It's not going to go this way or this way. So I know that this is 0, and I know that this is a true statement. So I'm just going to write this right here. Fn is equal to 14.7 cosine of 20, which I can put in the calculator and find a value for, which I will do in a moment. Now if we go down to hanging block Y, this hanging block is 0.2 kilograms, so negative 0.2 A, because the acceleration of the two blocks will be equal, because they're connected by the same string, equals F2 minus, this is the mass of the hanging block, so 0.2 for mass times 9.8 for acceleration of gravity. We already took care of the sign with that right there. So we get negative 0.2a equals Ft minus 1.96. So if I move this over here, whoops. By adding 1.96 to both sides, I can get Ft by itself. Then if I go all the way to the top, back to this equation, I'm going to do one more step here, and then I'm going to move it to the bottom. I get 1.5a equals Ft minus mu is 0.2, Fn is equal to 5.03, because that is 14.7 times the cosine of 20. Oops, let me check that a minute. That is 13.08. I use sine instead of cosine by accident in the calculator. Minus 5.03. And all of this here at the end is just a number. So I can simplify that down to 1.5a equals Ft minus 7.65. And be careful about your positive and negative signs in these problems. All right, so now I'm going to take that right there. I'm going to move it down to the bottom to do my math together. So I have, and I'm going to move this over to this side to solve it for t. So I end up with 1.5a plus 7.65 equals Ft. Oops. This is my slider there. Set these two equal. I'm going to move the 1.5 over here. So it's going to become, I'll show you my work for it, negative, equals, and I'm going to move my 1.96 over here. That becomes negative as well. So this is negative 1.7a, and this one is 5.69. Divide both sides by 1.7, and I get 3.35 meters per second squared. Now I got a negative sign. That tells me that my answer is good, but my hypothesis about the direction of motion was incorrect, so that the system is actually going this way, and this block is going up, and this one is sliding down the board. Now, I also asked for the force of tension, so I am going to go back to this equation right here, which is a nice simple relationship between A and T, and I'm going to substitute in my value for A, so let me rewrite it first. It's already solved for Ft, so I don't even have to do algebra. But substituting back in, I keep my negative sign, and then I'm going to put in the calculator 1.5 times 3.35 equals 5.03. negative, plus 7.65 equals Ft. And that gives me 2.62 positive. Newtons equals Ft. And here's my acceleration. And my direction is to the left. And that is the end of the problem.